Hello, my pre-calculus student. In this video, we are going to graph the cosecant function. F of x equals a cosecant of bx, where a and b are real numbers. Let's begin to review what is a vertical asymptote. A vertical asymptote is a vertical line that the graph approaches but does not intersect. So you can see right here for the cosecant function, you can see that they for every period there are three adjacent vertical asymptotes. Now one of the vertical asymptote is the y-axis. You might not be able to see it, so let me draw it on top of it so you can see. Okay, so next we are going to review the cosecant function. Now the cosecant of the angle theta is the reciprocal of sine. So it means that if first let's grab the value of, let's go ahead and compare the table for the sine function first. So we'll have the table for the sine function. So when you go count the clockwise, the period is 2 pi. And then the three middle number will be pi over 2, pi, and 3 pi over 2. So you can see right here that you go one complete rotation around the angle 0. So you 0 and then 90, 180, 270, and you come back to where you begin, which is 360 degrees. Or to 2 pi. So psi is the y value. So psi of theta is the y value. So psi of 0 is 0. Again, psi theta is the y value. So psi of 90 degrees or pi over 2 is 1. Psi of pi is 0. 3 pi over 2 is -1, and 2 pi is 0. Now, since cosecant is a reciprocal of sine, so for our cosecant function, so think about 1 divided by 0 will be undefined. So that will be your first vertical asymptote. X equals 0. You see, so I'm looking for one period only, x equals 0. And then if psi is 1, 1 divided by 1 is still 1. So the point will be pi over 2. So this is pi over 2, 1. And then if psi of pi is 0, 1 divided by 0 will be undefined. So this will be your second vertical asymptote. So this will be x equals pi. So there are three consecutive vertical asymptotes. So far we have 2, and we keep going. -1, so cosecant again is reciprocal of sine. So 1 divided by -1 is -1. So this will be the point right here. 3 pi over 2 comma -1. And 2 pi will be undivided because 1 divided by 0. You cannot have 0 in your denominator. So now there we are. So since the sine function have 3x intercept, then that 3x intercept become 3 vertical asymptote for the cosecant function. So here we are. So now if you want, I can go ahead and just get the psi function so that you can have an idea how the psi function. So this is the graph of the psi function for one period. So you can see right here that if we want to graph the cosecant, we just go ahead and graph the psi function first, and where the x in the intercept of the psi function, we need to get the vertical asymptote. And last thing, we just go ahead and draw the U shape between two consecutive vertical asymptotes. So if you think about for the psi graph, this part of the graph open down, then for the cosecant it will be the reciprocal, so the U shape will be open up. So let's write out our observation for the cosecant function. So let's start with the domain first. You can see right here that what we're doing right here is only one period, which is 2 pi, and then we also graph at additional periods on the left. So our domain, we can say that all the number x, the collection of all it will be the set or the collection of all the number x, such that we don't want to include the vertical asymptote, which is where the x intercept for the psi function. So it means x cannot be multiple of pi, so n times pi, where n is the element of the set of integer. So that will be the domain. Now let's move on to the range. You can see right here that there are two different U shapes, one up and up and one up and down. The one that open up have the minimum or the vertex is at 1. The one open down have the maximum or the vertex is at -1. So I'm going to put the range, I'm using the interval notation. So -infinity to -1, and I'm using the square bracket to include that union. So this will be for the U shape that open down. For the one open up will be from 1 to positive infinity. So now we have the domain, we have the range. Now let's talk about the x-intercept. The cosecant function doesn't have the x-intercept, so x-intercept none. Now how about the y-intercept? So we also can say that none of this U shape intercept with the y-axis, so therefore we can conclude that the y-intercept no. So we don't have the y-intercept. Let's talk about the vertical asymptote. So we can see that for every period of 2 pi, there are 3 consecutive vertical asymptotes: 0, 1 pi, 2 pi, so it's just a multiple of pi. So therefore we can write them as x equal n times pi. It means multiple of pi, where n is an element of the set of integer. So n can be -1, -2, or n can be 0, 1, 2. And one more, which is the symmetry. Symmetry is the point 0, 0. In this case, we can conclude that the cosecant function is the odd function. Okay, now we are going to graph the cosecant function. Before we graph, we are going to ask you to write these 5 steps. So far we just see the graph of cosecant function where the input, where the a and b, those two numbers, they both equal 1. So what happens when a and b, they don't equal 1? So these are the steps that we are going to follow. Step 1, we find the periods. Again, we assume that b is a positive real number. So the period will be 2 pi divided by b. If you remember, it will be the same as the period for the sine function. And next, you are going to use the dot curve graph to graph the sine function. So the a sine bx, you need to graph that sine function first with the amplitude is 8. After you graph the sine function, you go back and you need to, for the 3 x-intercept of the sine function, then you need to get the vertical line at each one of those 3 x-intercept of the sine function. And lastly, between 2 consecutive vertical asymptotes, because you have 3 of them, so you will end up with the U shape. So there are 2 U shapes between 3 consecutive vertical asymptotes. So make sure you write these steps down for us, please. Then we are going to practice now. Okay, so let's begin. Let's graph the cosecant function. F of x equal 3 times cosecant of 2x. Step 1. We unify the periods. So we take 2 pi divide by b. So our b is 2, so therefore the period is pi. Step 2. We are going to graph sine function, because cosecant is the reciprocal of sine. So I'm going to graph the sine function first. So in this case, we graph the function y equal 3 sine of 2x. So I'm just go ahead and make the table really quick for the sine function. So x, so we know that the period is pi. So we will divide the interval from 0 to pi into 4 equal parts. So we do pi over 2. I'm sorry, pi over 4. Fix this. So pi over 4, 2 pi over 4, or the same thing as pi over 2, and then 3 pi over 4. Next, we will multiply each one of our 5x value with the 2x. So that gives it 2 pi, pi over 2, and then 3 pi over 2. Now we will find sine. So we find sine of 2x. So again, if you look at 2x, these are just the 5 special angle on our unit circle. So sine of 0 will be 0, sine of pi over 2 will be 1, sine of pi 0. So if you remember the pattern for the y values of the sine function, that will be 0, 1, 0, negative 1, and 0. So there are 3 x in the step, and lastly you will multiply by 3 in front of your sine of 2x. So now you can see that your amplitude is 3. So you have 0, 3, 0, negative 3, 0. So this is how we graph the function 3 sine of 2x. Next step, we just go ahead and we go ahead and plot the 5 points. So let me just plot 5 points. So the point be 0, 0, pi over 4, 3, and 2 pi over 4, or the same thing as pi over 2, 0, 3 pi over 4, negative 3, and the fifth point will be pi comma 0. So this will be the graph of the sine function, and then we connect with the dash curve. So I'm going to go ahead and plot it in here. So this is 0, and pi over, so if we want to expand a little bit, I'm going to hit every 2 tick marks. So this will be my pi over 4, 2 pi over 4, 3 pi over 4, and then pi. So we plot the point now, 0, 0, pi over 4, 3, 1, 2, 3, 2 pi over 4, 0, 3 pi over 4, negative 3, 1, 2, 3, and pi 0. So this is the graph of sine. Now we don't want to graph the graph of sine, we just go ahead and connect them with the dashes curves, because that will be the guideline for us to graph our cosecant. So this is we're done with step 2. We graph the sine function. Step 3, we need to go ahead and graph vertical asymptote. Now there are 3 x in the step, so there are 3 vertical asymptotes. So we'll be at x equals 0, x equal 2 pi over 4, and the last one will be x equal pi. So I'm going to go ahead and use the red color to label my vertical asymptote. So there are 3 consecutive vertical asymptotes. So after that, the last step number 4, we just go ahead and sketch a U-shape. Between 2 adjacent vertical asymptote. Okay. So you can see right here, if for the sine function, this piece open down, then for our cosecant, my U will be opposite direction, to be open up. That's it. So we have our cosecant function graph. So this will be the graph of f of x equals 3 cosecant of 2x. So let's write down the summary. In this video, we learned this. How to graph the cosecant function. F of x equal a cosecant of bx. Thank you for watching this video. I will see you in class. Goodbye.